Hi everyone. Today we'll talk about collaborative text editing. The idea is to have multiple clients collaborate and edit the same document in parallel in a distributed system environment. There are different ways of solving this problem. We'll talk about differential synchronization, operational transformations, conflict-free replicated data types or CRDTs, and Fugue and Fugue Max, which is introduced by Dr. Martin Klebman, and credits to him for the same to solve this problem using this method and the overall architecture. Now, moving on to differential synchronization, let's consider a scenario where there are multiple clients trying to edit the same document in the server. Now, let's see how the interaction happens between one single client and the server. So the left side is the client and the right is the server side. So let's assume ABC is the content in the document. On the client side, we have a local doc and its shadow is basically the copy of the local doc, and the backup is like the previous version of the document. Similarly, on the server side, there'll be a server doc, a shadow copy, and a backup is the previous version, right? Now, if the client wants to add a character, say D, then the diff will be calculated between the local doc and the shadow. The diff between local doc and the shadow is the character addition D. So that we will get it as adding D at position 4 and say version is V2. Now this diff will be sent across to be patched with the server side on the server side, and once the patch is received, the server will apply the diff and it will update its uh, copies. Right now, in the meantime, so this will also get updated to shadow. So in the meantime, let's say there's another client wants to add a character E. Now the diff is calculated here and the character E will be added. So the version will be V3 and sorry, for the position is 5 and version is V3. So this diff will be sent across and it will be patched and it will be updated on the local doc, right? So that is how the differential synchronization works. Now let us consider that the client has added the characters uh, F, G, and H, and the diff is calculated. So it will be F at position 6. So the version will be say V4, and G at position 7, V4, and H at position 8, V4, right? So this diff will be sent across to be patched. Let's consider that the diff does not go through, it gets dropped. And in the meantime, there's another client that has updated the document as XYZ, right? When this request to add goes through, then the server will say that, hey, uh, I am no longer at version 4. Let's assume the server is at version 7 now after the update to add XYZ. So it will say that, hey, I'm not no longer at version 4. You need to update your local document. Then the local document will get updated with whatever is there on the server side as XYZ will get added. Now, uh, as you can see, the entries are lost and the client has to re-add the characters that need to be added. So uh, there is a probability of basically the client will have to re-edit the document based on what is updated on the server side in these cases. Let's conceive of the versioning as well on whether to use a Lamport clock or a vector clock. If a Lamport clock is basically updating the version with every operational change, as in this case that we discussed. So for every operation on the client side, the versioning on the client side will be updated. However, if you use the Lamport clock, there is a possibility that two clients have the same version and there is a conflict on the server side on which one to be taken. So it is better to use vector clocks in this scenario. Vector clock is nothing but a array of versioning. So say for if there are n clients, there'll be n entries in the array. So for client one, let's say the version updated is up to 4, and for client two, the number of entries or updates are just 1. And from client 3, the let's say the number of entries or updates are up to version 3. So this will be the vector that will be sent or vector clock that will be sent for every entry, the document, so that there are no conflicts. Okay. Now moving ahead, let's see how operational transformation solves this problem of differential synchronization. So even in this case, let's say the left is the client and the right is the server. ABC is the entry in the document, and the client wants to add D at position 4. This is sent across, but the position of D is transformed into a new position based on the characters in the server. So this way, the entries or the data entered by the client is not lost and it gets transformed to a position where it needs to be added. In the meantime, if there's another client that has added position E at position 4, it will be sent across and transformed and updated on the client side. So no entries either on the client or the server are lost, and it gets updated to the exact entry. So E will be added at position 4 and D will be moved to position 5 here, right? So both the client and the server are synced and there is no loss in data. However, there could be a case where based on the order in which the request arrive, the diffs arrive on the server side or on the even on the client side, any client side. The ordering could vary as ABCDE or ABCED based on the order in which it has arrived. So to avoid this situation, let's see how conflict-free replicated data types or CRDTs solve this problem. So if ABCD is the entry in the document, with each entry or character will have a position value that is calculated. So let's say for A it is 0.2, for B it is 0.4, C is at 0.6 and D is at 0.8 position. And if the client wants to add the character E between C and D, then the value or position of E is calculated by taking the average of its neighbors, that is C and D, that is 0.6 plus 0.8 by 2, that is 0.7, and it is added at the exact position. Now, let's assume there are two clients that are trying to add the same, that are trying to add two different characters at the same position. So client one is adding E at position 0.7 and client two is adding X at 0.7. Then the way CRDTs resolve this problem is by adding a random value uh, for the position. So for E, let's say with the random value added, the value position value is 0.712, and for X to 0.718. Based on these values calculated, the document gets updated as ABCEXT. Thus, the conflicts are resolved and there are no data loss as well. Characters are not lost. Let's see what is the problem of interleaving. Consider two clients, one client trying to enter Alice in Wonderland and client 2 entering Wonderland of Alice. Now, in client 1's case, A is at position 0.2, L at 0.4, I at 0.6, and so on. In client 2's the local document, W is at 0.2, O is at 0.4, N is at 0.6, and so on. Now, when these positions are merged, then the document might be entered as AWLOINCDEER, which is not what was intended by either client 1 or client 2. So this could occur in any of the above mentioned solutions for conflict-free, sorry, collaborative editing, text editing scenario. Let's see how Fugue and FugueMax solve this problem. In case of Fugue, there will be a tree that will be created where each node is a character that is added, and the characters of the left subtree of that node will be to the left of the character, and the characters on the right subtree of the node will be to the right of the character. And each node can have multiple left children and multiple right children. We'll see when that can occur. Tree is called a left origin tree because every character that is entered will be entered based on the character to its left. So this could be a sample left origin tree for the text A, B, C, D, E, F, where A and B are the left children of A, C, and D, E, F form the nodes in the right subtree of C, right? Now, we could have a scenario where A and B are two left children of C when there are two clients, a client 1 and client 2, trying to enter the character, one client trying to enter the character A before C, and another client trying to enter the character B before C. Let's move ahead and see how character entries happen. So if a client wants to enter character G after A and before B, then it will be added as the right tree, right node of the character A. That is, every entry will be based on the node's position will be based on its left character. That is, in this case, for G, it is A, and it will be a right child. Or it should be the leftmost child of its right subtree. Okay, so G is added to the right as a right child to A. Now let's consider H being added after A and before G. So for the entry A, H, G, B, C, D, F, if for H to be added, it will be the leftmost child of the right subtree of A. That is, it will be the left child of G in this tree. So that when traversing, it will be traversed as A, H, G, B, C, D, E, F. Right? So that's how the characters are entered in the left origin tree for FugueMax or Fugue. Now let's consider a use case where there are multiple clients trying to add the same entries at the same level. So in a document after G, one client is adding a list of fruits, the apple and bananas, and another client is adding a list of bakery items, that is bread and cake. So on either side, the entries will be to the right will be a right child of G, and when they are merged, it will be as two entries, that is two children of G, one having a list of fruits, another having a list of bakery items. This way, when traversing and updating the document, uh, it will be updated without interleaving. That is, the problem of interleaving is resolved, and it will be ordered based on the client IDs. Client ID is one way of ordering, but we could probably change based on how we intend to order. So let's assume client ID is the way, and in this case, based on the client ID, the fruits will appear first and then the bakery items. Now let's consider an example where we have three replicas, replica 1, 2, and 3. And replica 1 is trying to add A at position 0, 2 B at position 0, and 3 C at position 0. Now, based on the order in which the requests arrive, let's see how the document gets updated. So in one, once C arrives, it is updated as AC, and in 3, when B arrives, it is updated as BC. And in the meantime, if replica 1 inserts character X between A and C, it will be updated as AXC. And on the replica 3, when the character A arrives, it is updated as ABC. Right now, as you can see, this is the tree that gets formed when the requests arrive. So A, B, and C will be at the same level, and it will be uh, three right children of the root node, because all the characters A, B, and C are at position 0, and based on the ordering of the replica IDs, it will be A is the first right child, then B, and then C. Right now, when B arrives at replica 1, it is added between X and C. Now let's consider what determines the position of X, whether X should be after B or after A. This is based on two conditions that is mentioned by in the paper of Dr. Martin Kleppmann. Uh, Condition 1 is that the X is left origin, that is A, should be before B and B is before C. If this condition is satisfied, and the condition 2 is if B's left origin, that is root, is not the same as X's left origin, that is A. So X and the root and A are not the same. Then the result will be that X should come before B and B should come before C. So the ordering will be AX, BC. So X is anyway added as a right child of A, because as per this entry, X should come after A, right? So AX, BC will be the order in which the entries will be read based on these two conditions. So this is the same image that I have taken from the paper where Dr. Martin Kleppmann has discussed about fugue and fugue max. Now moving on, let's consider the more entries in the same workflow where replica 2 adds y between A and B. Then how eventually the document gets updated in the same order. So this will be the left origin tree that will be formed where y is added after A in the document, because y is added between A and B in replica 2. It will be the right node of A in the left origin tree, and it will come after X based on the ordering of the replica IDs. Now let's consider a case of tombstone. Tombstone is basically when the entries in the node are deleted. So this is the original tree or the initial tree where ABC are at level 1 and XYZ are at level 2, XY being the right node of A and C is yet to be added. So this will be AXYBC. Now Z is added after B and before C. So we add a node for Z, right? We added after B and before C. So it will be the right node of B in the left origin tree. Now, if B is deleted, we don't delete the node for B. It will just be marked with a tombstone character. Similarly, when X, any other node is deleted, it will be marked with a tombstone character, right? So that the node exists. And this way, even when reading, the ordering is never changed. It is still AYZC and the nodes will continue to remain. That is how the deletions are handled in Fugue and FugueMax. Now, moving on. In FugueMax, the difference between Fugue and FugueMax is that in FugueMax, another tree is created, a right origin tree, where the position in the right origin tree, the node that is added will be a left child to the character to its right. Right. So in the previous example, when X is added, it is B's, comes before B, so it will be the left child of B. And when Y is added, it is the um, left child of B again. It has to come before B. Oh, sorry. In this case, when X is added, it comes before C. So X will be the left child of C. When Y is added, it comes before B. So Y will be the left child of B. So in the right origin tree, Y will be the left child of B and X will be left child of C. This is useful in a case where the ordering will be based on the ordering of XY is based on the replica IDs, right? So in FugueMax, the ordering will be based on the parent node. So for Y, the parent is B, and for X, the parent is C. Now, based on the replica IDs ordering, the parents B and C will be read as BC. With the right origin tree, the ordering will be reversed as CB so that the child nodes will be read as X and Y. So the character ordering will be as read as AX, Y, BC. So that is how the ordering is determined in FugueMax. And okay, let me try to explain again. In FugueMax, there is another tree created, that is the right origin tree, which is based on the character to the right of the inserted character. So in the previous example, when X is inserted, its right character is C, and when Y is inserted, the right character is B. So in the right origin tree, the Y entry will be the left child of B, and X entry will be the right child of C. This is useful for ordering the characters. So based on the left origin tree, the entries can be read as AXYBC or AYXBC based on the ID of the replica nodes. But to keep it consistent, uh, the right origin tree is entered. In the case of FugueMax, the way the ordering happens is in the reverse order of the parent nodes. If X and Y are the entries and X's parents in the right origin tree are different, that is B and C, then the ordering of X and Y will be the reverse order of its parents. That is, it will the reverse order of the parents is CB. So the ordering of X and Y will be read as AXYBC. That is, X will come before Y, so it will be AXYBC. That is how the Fugemax uses the right origin tree for ordering. Now, moving on, how to handle rich text. That is, let's say client one wants to add bold, make bold Alice in the text Alice in Wonderland, and client two wants in Wonderland to be bold in the text Alice in Wonderland. So when they are combined based on the tree structure, it can be added as um, in a jumbled way, which is not understandable for the rich text or document, or uh, it is not updated correctly. So the way that will be handled is basically the rich text edits will be a list of entries. So let's say L1 is making bold Alice in, and L2 is making bold in Wonderland. So this will be applied in a single order. So L1 will be applied first, making Alice in as bold, and then L2 will be applied, making in Wonderland as bold. Thus, the rich text also gets handled without causing any issues. Now, adding comments in the document, how will that be added? Basically, each character will be mapped to a comment entry, and based on whichever position the comment is added, that entry in the list or array will get updated with the comment or position of the comment. That is how the comments will be added or to the document. Now let's move on to the overall architecture. A simple architecture will be for a client to talk to a WebSocket, and from the WebSocket, the request is sent to a queue. Uh, that will ensure the ordering of the request. And then from the queue, the server takes the entries and updates the database and caches the positions for quick updates or to the client or multiple clients of the database, right? So this is a simple architecture. Now let's consider multiple clients adding entries to the WebSocket, and from the WebSocket queue, then server, right? WebSocket to queue, queue to server, and then to the database will be which will be an RDBMS. And there'll be an API gateway which will be added so that the multiple services like the comments, the rich text server, and the authentication and authorization are kept away from the client's perspective. So from a client's perspective, there is a single point of entry, that is the API gateway, and everything internal will be handled automatically. We'll keep the authentication and authorization at the API gateway level. So when the client requests for updating a document, it will be first authenticated based on the entries in the RDBMS. And then we have separate services for rich text updation and comments updation. The DB used for each of them will be a NoSQL. And the advantage of keeping separate services is that even if one service goes down, the document is still available to be updated for the clients. And the document will be stored in an RDBMS with a time series database keeping track of all the changes that happen to the document, and a cache where we'll store the changes that need to be uh, made available for the different clients at any point in time for quick reading or low latency reading. So this will be the overall architecture for the collaborative text editing. Hope this was helpful. Uh, do let me know if there are any questions or comments. And thank you very much.